Hello everyone, welcome to the channel. As we have done our exercise 6.1, now we need to understand exercise 6.2 questions which are given. But before that, we need to understand about the basic terms and theorems and axioms which are needed to solve these questions. So in this video, we are going to understand about these basic terms and other theorems and axioms which are involved. So let us take the first one, that is about parallel lines and a transversal. Here we are having two lines. This one is your line M, another line is also given. This line is line N, and a line L is intersecting the line M and line N. It intersect at point P and Q. So this line L, is a transversal line. And here we have seen that line L intersect line M and line N at point P and point Q. Here it makes some angles. Let us name these angles: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. We are having here exterior angles. Exterior angles means the angles which are in outside situation. Here it is angle 1, angle 2, angle 7 and angle 8. These are all exterior angles. Here it also form interior angles. Interior angle is angle 4, angle 3, angle 5 and angle 6. These are all interior angles. Now let us write down the pair of angles which are formed when a transversal line intersect two other lines. So here we are having about corresponding angles. This pair is having such a way that one angle is on outside and one angle will be inside. So angle 2 and angle 6 are corresponding angles. Angle 1 and angle 5 are corresponding angles. This pair is what corresponding angles. Similarly, angle 4 and angle 8 is a pair of corresponding angles. Angle 3 and angle 7 is a pair of corresponding angles. Now similarly, we are having another type of angle like alternate interior angles. So angle 4 and angle 6 is your alternate interior angles. It makes Z in this way. So this angle is alternate angles. These angles are a pair of alternate angles. Similarly, we are having here angle 3 and angle 5 is alternate interior angles. Now on the basis of same, we are having a pair of angle we call as alternate exterior angles. In alternate exterior angles, we are having angle 1 and angle 7, then angle 2 and angle 8 is also a pair of alternate exterior angles. Angle 1 you can see here and angle 7 here. So it should be like in the exterior part, and alternate means in the formation of Z. We need to compare and we can find that these are all the pair of alternate exterior angles. Another type of pair of angles which are there here is interior angles on same side of the transversal. In this one we find that angle 4 and angle 5 is interior angle, that is on the same side of transversal. Similarly we have another pair, angle 3 and angle 6, which is an interior angle on the same side of transversal. This interior angle on the same side of transversal is also called consecutive interior angles. Consecutive interior angles. Now let's move on to the next part. Here this time we see that the lines, these line M and line N is parallel to each other. Line M and line N is parallel to each other, and your line L intersect these two parallel lines. Line L intersect these two parallel lines. So here let us redraw the angles which are formed. So angle 1 is here, angle 2, angle 3, angle 4, 5, 6, 7 and 8. These angles are formed. Line L is your transversal. These lines particularly intersect at point P and Q. Now measure any pair of corresponding angles. So we find a relationship that the corresponding angles which are formed when a transversal line intersect these two parallel lines, they will be equal to each other also. So angle 1 is a corresponding angle with a pair of angle 5. This angle 1 and angle 5 is equal to each other. We are having another like angle 2 and angle 6 is corresponding angle. We find that angle 2 and angle 6 is equal. Then angle 4 and angle 8 is corresponding angles, a pair. Angle 4 is equal to angle 8, and angle 3 and angle 7 is corresponding angle. Angle 3 is equal to angle 7. So these corresponding pair of angles will be equal to each other when the line L used to intersect the other lines and the other lines are parallel to each other. In that case the corresponding angles are equal to each other. So we come across axiom 6.3, and this axiom is called if a transversal intersect two parallel lines, then each pair of corresponding angles are equal. So this axiom is also called corresponding angles axiom. Now let's move on to the next one. Here we are having converse of corresponding angle axiom. What is given in this statement? That it is your axiom 6.4. It is the statement as if the transversal intersect two lines such that a pair of corresponding angles is equal, then two lines are parallel to each other. This is your converse of corresponding angle axiom. So we come across that here two lines are there, and through these two lines a transversal intersect, and if you find a pair of corresponding angles are equal, then the two lines will be parallel to each other. That is what we find here. So we can see that, let us say these two lines are there. It is unknown that these two lines are parallel or something else. A transversal line L intersect these two lines M and N, and in the corresponding pair of angles, angle 1 and angle 2, if these two lines are equal to each other, which are the corresponding angles, then I can say that line L, line M and line N are parallel to each other. This is what axiom 6.4 which is given. Now let's move on to the next one. Here we need to see that what is given in theorem 6.2. In theorem 6.2, it is given in the form of statement that if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. You see this that these two lines, line M and line N, is parallel to each other. Line M is parallel to line N, and a transversal line L intersect at point P and Q. Then the alternate interior angle, like angle 1 and angle 2, angle 1 and angle 2 are alternate interior angles. So these interior angles which are alternate to each other will be equal. So that is what theorem 6.2 show us. Now moving further with the theorem 6.2, then after we need to discuss theorem 6.3. It is the converse of theorem 6.2. In this it is given that if a transversal intersect two lines, now these two lines are parallel to each other or may not be parallel to each other, we are unknown. So here a transversal intersects two lines such that a pair of alternate interior angles is equal, then two lines are parallel. So it is a converse of theorem 6.2, where we are unknown that the lines are either may be parallel or may not be parallel. So here if I denote that line M and line N are two lines, and through these two lines another line L intersect these two lines at point P and Q, and we find that alternate interior angles, angle 1 and angle 2, are equal, and angle 1 and angle 2 are your alternate interior angles, and these angles are equal, then on the basis of that we can say that line M is parallel to line N. So this is what the converse of theorem 6.2, and it is given as theorem 6.3. Now moving further with the next theorem, that is theorem 6.4. Theorem 6.4, the statement is given that if a transversal intersect two parallel lines, then each pair of interior angles is equal to 180 degree. That is, the each pair of interior angles on the same side of the transversal is supplementary. So we see that here two parallel lines, line M and line N, these two lines are parallel to each other. Another line, that is line L, intersect these two parallel lines. Now we are having interior angles like angle 1 and angle 2, that is on the same side. Angle 1 and angle 2 are your interior angles, and these two interior angles they are present on the same side, present on same side of transversal. So the sum of these two angles, angle 1 and angle 2, is 180 degree. That is supplementary angle. Moving further to next theorem, that is theorem 6.5. Theorem 6.5 is, if a transversal intersect two lines, if a transversal intersect two lines such that a pair of interior angles on the same side of the transversal is supplementary, then two lines are parallel to each other. So we can say that theorem 6.5 is converse of theorem 6.4. So here in this theorem we come across that if you are having two lines, these two lines are parallel to each other, we are not aware or we don't know. So line M and line N is there. Another line, line L, is your transversal line. These two lines are intersected by the line L at point P and Q. If I find that the interior angles like 1 and angle 2 are interior angles on the same side, these are anterior angles on the same side, and we are observing that angle 1 plus angle 2 is equal to 180 degree. The sum of the pair of these two angles is 180 degrees supplementary. So on the basis of that, we can say that then definitely these two lines, line M and line N, will be parallel to each other. That is what given in theorem 6.5. Moving further in the chapter, let's discuss about lines parallel to the same line. Lines parallel to the same lines. So here it is given that if two lines are parallel to the same line, now will they parallel to each other? So for this we need to have three lines like line L, line M, line N, and a transversal line, line T, is a line, transversal line T, used to intersect these lines. And we are having that in this figure we see that line M is parallel to line L and line N is parallel to line L, and your line T is transversal line which intersect line L, line M and line N. So we see that line M is parallel to line L. Line M is parallel to line L means the corresponding angles, angle 1 and angle 2, these are corresponding angles. Angle 1 and angle 2 are corresponding angles, and these corresponding angles will be equal, angle 1 and angle 2, if these two lines are parallel. Now line N and line L are parallel to each other, so this is angle 3. So angle 1 and angle 3 are corresponding angles, and these corresponding angles will be equal. Angle 1 is equal to angle 3. So on the basis of your corresponding angle axiom, we have written these two angles pair are equal. Now from these two we can compare and we can say that angle 2 is also equal to angle 3. If angle 2 and angle 3 are equal, so these are all the pair of angles which are corresponding angles. If these corresponding angles are equal, it means that line M is parallel to line N. On the basis of your converse of corresponding angle axiom. Moving further now to theorem 6.6. Here the theorem 6.6 is given that lines which are parallel to the same line are parallel to each other. So this is what we come across from the previous sheet, that lines parallel to the same lines, what happen? They will be parallel to each other. So in this way we come across the important theorems and axioms and important terms. Before moving to the next exercise, particularly some examples and your exercise 6.2 for chapter lines and angles, hopefully you will be going through this particular video and try to understand.